I'd like to talk to you a little bit more about component forms, some properties that are going to be very useful to you. I want you to read a little math note. Sometimes if and only if is written with this IFF, and so that's just a really neat shorthand that can be used. So if you do see if you see if with two F's on it, I haven't stopped being grammatically correct. I'm just using a mathematical shorthand. So anyway, if we have two vectors, V with components V1, V2, and U with components U1, U2, then the first thing is what we showed in an example, that two vectors are considered equal if, and only if, their components are equal. So you can compare components to determine whether or not vectors are equal, and vice versa. So you can compare components to prove they're equal, or if you know they're equal, you get this automatically. So you can use that in solving or proving something. The second one is something you probably could have already guessed. The magnitude of a vector V is just the square of its component, the sum of the squares of its component with a square root, right? It's Pythagorean theorem. So it's no biggie there. The third one I want to talk a lot about because this is a lot more important than it initially appears. So if the magnitude of a vector is equal to 1, then that is called a unit vector. So in mathematics, when you hear the word unit, you usually can think length 1. So if from beyond your career here in mathematics, if you see something and you hear the word unit, think the word 1. So you might hear the word roots of unity for those of you who go study more math later. But that unit means 1. And so sometimes a unit vector is written at this V hat. I'm going to try to avoid that terminology for generic vectors. But if I do write that, just note that I'm using that as a unit vector. So anyway, but the point is, if a vector is magnitude 1, we call that vector a unit vector. And finally, if a vector has magnitude 0, that's only true, so it's if and only if. That means this tells me that, or if I know this, it tells me that. That's what if and only if means. It means if I know this, I automatically know that, and if I know this, I automatically know that. It goes both ways. The magnitude 0, if and only if, the vector is what we call a zero vector. And that just means it has zeros for components. Which means there's nothing. You don't go anywhere. Like if you think about going somewhere, you add that vector and you ain't gone anywhere. And again, if it has 0 components, that's pretty simple, right? It's 0 squared plus 0 squared, square root, nothing. So those are really just some important key pieces to keep in mind as you are dealing with vectors.